Okay, we're going to continue using elimination to solve a system equation, but this time the equations aren't going to be set up as nicely at first. We're going to have to kind of manipulate them a little bit to get them where we want them. Okay, so remember, elimination is where we need to have either the x's or the y's matching. So in this case, we're saying which terms match. So I'm circling in red and in blue, and you can see, negative 7 and 5, those don't match. 3 and 4, those don't match. So if I subtract or adding, nothing's going to go down to 0. I need to make something. I need to change the equations so that I can force this to happen. Okay. So neither match or are opposites. So we're going to make them match using multiplication. Just going to fill in here. There we go. All right. We'll go ahead and read that last one. Since 7 and 5 or 3 and 4 are not multiples of each other, we will choose either x or y and multiply both equations. So that's what I kind of skipped over there. I should have read that. All right. So we're going to use multiplication to make the match. So choose one of the two variables to eliminate. It doesn't matter which one because they don't necessarily work nicely with each other. Sometimes you get numbers like you'll get 6 and 2. Okay, I can easily turn 2 into 6, something like that. Well, with these ones, negative 7 and 5, I can't easily turn one into the other, or 3 and 4, I can't easily turn one into the other. So determine what to multiply each equation by to end up with opposites. So once we choose either x's or y's, it doesn't matter again which one we choose, then we're going to determine what to multiply each equation by to get our opposites for that variable. And then we're going to use elimination to solve. So in this case, we're going to eliminate the x terms first simply because that's what I chose. You could have chosen the y terms. It would have been perfectly fine. You would have gone a different path than I'm going to go right now, but you would still arrive at the same solution at the very end. So if I want the x's to match, the lowest common multiple of 7 and 5 is 35. So it's kind of multiplying by the opposites. So I'm going to multiply the whole first equation by 5 so that I turn this into negative 35. And I'm going to multiply the whole second equation by 7. So I turn this into positive 35. But remember, I have to multiply each and every piece. I can't just turn the beginning into negative 35 and 35 and then not change the rest of it. If I'm changing one part of the equation, I have to change the whole thing. Because really, I'm not changing it. I'm just increasing the entire thing by a multiple of 5. Okay, so it's actually the exact same equation, just with bigger numbers. So when I multiply, I get negative 35, x on the front, which is what I wanted. And then 5 times 3y is 15y. And then 5 times 25 is 125. Now, I'm going to multiply the whole second one by 7. So 7 times 5 is 35x. 7 times 4y is 28y. And 7 times negative 24 is negative 168. So now I've manipulated this to the point where I have these two equations and I have these two terms that match. So I can add straight down. So negative 35x plus 35x cancels out. They're opposites of each other. So anytime I add opposites, they become 0. They cancel out. So now I can add the y straight down. So 15y plus 28y, I get 43y. And 125 minus 128, and it's plus negative 128. But I know that they're opposites, so I'm going to subtract, and I actually get negative 43 again. So now I'm going to undo that multiplication by using division. So 43 divided by 43 is 1. Negative 43 divided by 43 is also 1, but it's negative 1. So make sure that you don't forget that negative sign there. So I know, oh, that animated in the wrong order. So this should say negative 1. Okay, so now you can see that I have half of my solution. I need to go back and choose either one of the two equations to plug in negative 1 for y to find out. So Again, for whatever reason on these videos, I tend to like that second equation. Doesn't matter, I can choose the first one if I want to. I just like that second one again. So I'm going to plug in -1 for y, and I'm going to solve for x. So now I have 4 times -1, that gives me -4. So now I'm going to start getting x by itself. I'm going to solve, so I'm going to add 4 to both sides. So I undo that -4, -4 plus 4 cancels out. So I have 5x equals -20. I'm going to undo that multiplication using division. 5 divided by 5 cancels, and -20 divided by 5 is -4. So now I have the rest of my solution. So the solution is going to be -4, -1. All right, so we have another one of these, and again it says which terms match. So with this one I'm showing you -9 and -5, those don't match. -5 and -3, those don't match. So neither one matches. We're going to use multiplication again to figure this out. Again, since neither one are multiples of each other, 5 and 9 can't easily turn one to the other. 5 and 3 can't easily turn one to the other. So we're going to choose either x or y, since neither one is easier than the other. And we're going to choose what to multiply by to get opposites. So in this one in class, I let students choose what they're going to do here. So I'm going to minimize really quick, and I'm going to turn on my page marker so that I can write this out. So in this case, if I were to choose the x's, I would want to multiply the whole first one by 5 and the whole second one by 9, because 5 and 9 aren't multiples of each other, and the lowest common multiple is 45. Or I could choose, whoops, I don't know why I did that. I was trying to clear that out. There we go. I accidentally marked it. And then if I did 5 and 3, well, again, the lowest common multiple there is 15. So let's go ahead and look at 5 and 3. This time we'll look at the y's. So I'm going to multiply this whole equation by 3, and I'm going to multiply this whole equation by 5. One thing I do want to note on here is they're both negative. So if I want them to be opposites, I can choose one of them to be negative when I multiply, so it flips it to a positive. You don't have to do this step, but then that way they end up being opposites of each other. So if I go -3 times -9, I get positive 27x. And then -3 times -5y, I get positive 15y. Whoop. Wrote that funny. Equals, and -3 times 0, well, that's just 0. All right. And then I have negative 15, and you know what? I'm going to type this. So times -3. I'm going to move that over here just so it's a little neater because my pen tool is kind of funky. Whoa, that's weird. Okay. 5. So I'm just putting that back because when I hit that trash can thing, it got rid of everything, of course. All right. So I get -20, it was positive 27x when I did -3 times -9y, and then plus 15y, because negative times a negative is positive. 5 times 3 is 15, and then equals 0. All right. So that just made it a little bit neater there anyway. All right, so the next one I'm going to go 5 times -5, and I get -25x. And then 5 times -3y, I get -15y equals, and then 2 times 5, I get 10. So make sure when you go through and you're doing this, you're multiplying every single piece by the chosen multiple, okay? So I'm going to go ahead and draw the line. And we're going to add straight down. Because they're opposites, I'm going to add straight down. So in this case, I have 27x plus -25. So when I say plus negative, I know I'm going to actually subtract. So I have 2x. The 15s cancel out, right? So 15 minus 15 is 0, equals 0 plus 10 is 10. All right? So now I'm going to divide. And I don't know if I actually have my divide symbol here because that's a special symbol I put in there. So I'm going to undo that multiplication by dividing by 2 on both sides. Okay, so you can see that, divide by 2. I just wrote that in there a little funny. So I'm dividing by 2 on both sides, like that. And now on this side, 2 divided by 2 cancels out, so I have x equals 10 divided by 2 is 5. So now I have one part of my solution. I need to go back and I need to choose one of the equations. I can choose one of the 2 originals. I can choose one of the 2 that I manipulated. It actually doesn't matter which one I choose. So since in a lot of my videos I keep choosing equation number 2, I'm going to go ahead and choose the first one. So I have negative 9x minus 5y equals 0. So here's the equation I'm choosing, but I know that x is 5, so I'm going to replace that with 5. I'm going to substitute that in, and now we're going to solve. So I'm going to have negative 45 minus 5y, equals 0. And so now that I have the multiplication done here, I'm going to start solving for y. So I'm going to undo the subtraction here. I'm going to add 45 to both sides, like that. Okay, so I'm going to go ahead and draw my line here. Whoop. And I have 45, negative 45 plus 45 cancels out. So I have, got rid of my text box there. I have negative 5y equals positive 45. Okay. And so now I want to do the same thing that I did on the other one. I'm going to divide both sides by, I'm going to undo that multiplication by dividing. So don't forget to take the negative with it, because that definitely would change the problem if you didn't do that. You don't want to leave that negative behind. So now here's my line going right through my partial divide symbol there. So negative 5 divided by negative 5 cancels out, so that's y equals, and 45 divided by negative 5 is negative 9. So my solution is 5 and negative 9. By chance, we see the 9 and we see the 5. That's a little bit coincidence on this one. Don't take that as a pattern that that's going to be where you find your solution. It just by chance happened that way. So in this case, our solution is 5 and negative 9. Now, if you would have started with the x's and found x first, found y first, so you eliminated the x's and found y first, and then found x, you would still arrive at the same equation. All right, so that is using elimination with multiplication to solve a system of equations. I hope that helped, and I'll see you on the next video.